So this next one is concepts of measures of variation. And another word for variation is just variety. So we're going to be able to tell some things about comparing some data. So if we look at these two football teams, their height in inches are underneath. Now, if you take a look, to me, it looks like Team A, they have their heights pretty close together. You have 73, 75, 76, 78, and 78. And if I look at their heights, they all pretty much look to be close together. So I'm going to put that underneath. So these heights, in my opinion, are close together. And when I look at Team B, look at the second and the third player. They are very different in height. We have 76, 70, 82, 77, and 75. So if I'm comparing these definitely look out like their players are more spread out in their height differences. Now, these two teams here, their average is determined. So mean is the same thing as average. So their players are added, the heights are added together and then divided, added together and divided. So the average height for the first team is 76. And the average team, or the average height for Team B is also the same. So if I was only given that the average height of each player was 76 inches and I wasn't given these two pictures, I would say that both teams have relatively the same height of players. But you can clearly see by the pictures that you don't. So this measure of variation right here with the average, it does not tell us enough information because it does not tell us anything about the variety. Doesn't tell me anything about how spread out this data is. So the average would not be a very good measure of variation because I didn't figure anything out. So another type is the range. Maybe that will tell us some more information. So to find the range, we take the greatest value and we subtract the least value or the smallest value. So let's do this for both teams. So I have Team A and Team B. So I need to figure out the tallest player and subtract the shortest player. So if I go back up, Team A, the shortest player is 73 and the tallest player is 78. For Team B, the shortest player is 70 and the tallest player is 82. So for Team A, I have 78 minus 73. So that gives me 5 inches for the range. For Team B, I have 82 minus 70, which is 12 inches. So that means the difference is 5 inches from the shortest to the tallest. And for Team B, the difference is 12. So if I compare those, 12 is much higher. So what this tells me is that Team B has a greater variety of heights. Or you could also say that the players' heights are more spread out. So in this example, the average didn't tell me anything, but the range gave me a lot of good data. There are 2 questions on the next page that have you just finding the range. Go ahead and pause the video and figure out those range values. So for the first one, you should have gotten 35. And for the second one, you should have gotten 45 3/10. Now, make sure your degree symbol is nice and small so that it doesn't look like a 0. Now, another measure of variation is something called quartiles. Now, quartiles have 4 distinct steps on how to figure these out. I'm going to write down the steps while we solve this problem, and then you're going to be able to practice 2 of these on your own. So this data is telling us, well, we don't have a real world context with this one. We just have information. So step 1 is going to be to put the data in order from least to greatest. And as you can see, here's the data, and it's already put in order from least to greatest for us, so we don't have to worry about that. Step 2 is going to be to find the median. And the median sounds like the middle. We call that quartile 2. And we use a method called ping pong. We go from least to greatest, and we cross out as we go. Least to greatest, 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 least to greatest. So if I put a line here, it cuts the data in half. I have 1, 2, 3, 4, 5, 6 numbers on the left side, and 1, 2, 3, 4, 5, 6 numbers on the right side. So now I have to figure out the number that is between here. So when we're between, so quartile 2, we take the average of the 2 numbers. So I'm going to take 28, I'm going to add 30, and I'm going to divide by 2 to get 29. So quartile 2 has a value of 29. Step number 3. We are going to find the median again, but this time we're going to find it of the lower half. And we call that quartile 1. So I'm going to cover up all of these values. I don't need them right now. I'm only dealing with the lower quartile. And I'm going to ping pong again. Now I'm going to put my diagonals in the opposite direction so I can see which ones I've crossed out from the first time and which ones I'm crossing out from this time. So least to greatest, least to greatest, least to greatest. Again, I'm between. So for quartile 1, I'm going to take 17. I'm going to add 21 and divide by 2 to get 19. So now I have 3, 3. My final step is to find the median of the upper half now. And we call this quartile 3. So now I'm these upper half, these higher numbers, I'm going to ping pong again, and I'm going to do my diagonals in the opposite direction again. So least to greatest, least to greatest, least to greatest. So I'm going to put my value right there. So now in each quartile, in each quarter, there are only 3 pieces of data. So again, I'm between, so I have to take the average of those 2 numbers to figure out what comes between it. And I would have 41. So those are your 4 steps. Put the data in order, and then you find the median value 3 different times. Now, the reason why we put the data into quartiles is it tells us information. So these are math scores of 600 students on a standardized test, and they've put into order. So 380, 466, and 547. So I can say that 25% of students scored between a 0 and a 380. 25% scored between 380 and 466. Or I could say 50%, if I put these 2 together, scored a 466 or lower. So this information, quartiles, just tells us about percentages. Of the data. And there's a lot of different questions that you could be asked about this. Now, the next two questions, you are going to try to find those 3 quartiles by breaking the data up. So if you need to go back to these 4 steps, I would definitely use them to help you out. So pause the video and then check your answers when you're done. After you put the numbers in order from least to greatest, it's always important to recount them to make sure that you didn't miss any. And I would definitely suggest always doing this in pencil so that you don't make a mistake. And always start farthest to the left side of your paper because as you can see, you're writing very long rows of numbers. And if you break it into 2, it's going to make it a lot more confusing. For this example, your 3 quartiles, only one of them was between 2 numbers, and in quartile 1 and quartile 3, it was an actual number, so you can go ahead and just circle it. That is the value, so you don't have to do any math to figure out those 2 quartiles. So here's the answer for the last one. And a great idea to make sure that you've done this correctly is when you're done, wherever you drew your circle or your line, you should have the same number of data points in each part. So we're breaking this into 4 sections, so you should have the same number in each section. So from here, there are 3. From here, there are 3. From here, there are 3. And from here, there are 3. When one of your quartiles is the data number, you no longer include it as the lower half or the upper half. It's kind of a number by itself. We include both numbers when it's the quartile is between. So that's why I did not include 4 and 8/10 or 9 and 3/10 when I was comparing how many numbers were broken up into each section.